Very good morning to all of you. This is the fourth lecture of our subject non-conventional machining. Okay, in previous lecture we already studied the why do we need advanced machining process. Then we have gone for the major characteristics. Okay, also we have seen classification of non-conventional machining. Now today we'll start with the new point, that is overview of advanced machining processes, or you can call overview of non-conventional machining processes. Okay, so whatever the processes we have seen, or whatever processes I have introduced during the classification. So in this overview of advanced machining process, in this point I am going to explain the working principle of each and every process. Okay, now in that working principle is what is the history of that process. Okay, how the material is going to remove from the workpiece using that method. Okay, what is the principle behind that, that we are going to see now. This overview of advanced machining process, this topic I have divided into the two parts. In the first part we'll take the overview of mechanically energy based processes and electrically energy based process. Now in the mechanically energy based processes, we know that we have the four processes. First is the abrasive jet machining, then water jet machining. Okay, in short, AJM, WJM, and the combination of that two, it is called abrasive water jet machining, AWJM. And the fourth one is the ultrasonic machining. So three, these four processes are belongs to the mechanically energy based processes. Okay, and whatever I have shown the last one, no, EDM, that is electric discharge machining. This is belongs to the electrically energy based processes, or you can call in combine with the thermal, that is thermoelectric process. Okay, so and in the second part we will see the remaining processes. So let us begin with the first. Okay, before that, whether my voice is audible, everyone? Are you getting my voice? Okay. So now let us see the working principle of some of non-conventional machining processes or the advanced machining processes. Now, to understand the better concept of any process or anything, we should go with some other way. That means by taking the some examples or the day-to-day life events. Okay, so to understand them in a better way, consider some examples of events which we see in every day in our life. Okay, so if you see the first figure, okay, so this first figure, so this figure shows that water is coming from the this tap. Correct, water is coming from this tap. I have shown the direction of the water also. Okay, here I am taking the example of our day-to-day life. Okay, water is coming from the one tap. Okay, and all of you have the water tap in our home or your home also. Okay, so this is general thing. If now in this condition or in this situation, if we put a wooden piece or wooden block under this tap, under this tap, okay, which is I have shown by this here you can see also. Okay, I have put that wooden block or wooden piece under that tap. Okay, now you will find that after a few days a small craters or the small, I can say pieces, okay, has been formed in the wooden block. Okay, if water will come through that tap continuously, and that water, if that water will impinge, or I can say it will strike on the your wooden piece, then what happen after for example 1 week or 10 days, what you will get, you will observe that small craters or small piece of that wooden block will be from on that surface. Okay, now here our question arises is that how that water is able to cut that wood. This is general question. Okay, I repeat, here what question will arise, that how water is able to cut that wooden block. Correct. Now, because how this question is arise, because we studied that tool material should be harder than workpiece material. This is our theory from the our conventional manufacturing process or machining process. Our tool material should be harder than the our that workpiece material. But here a reverse situation is there. Okay, water is going to cut that wood. Correct, because small pattern is what that material removal is taking place. Okay, so now because here nothing like a tool is there. Okay, only water is falling on that wooden block, and still it is able to create a small crater over there. Okay, over here on the surface of the wood. Correct. So now we'll take another situation. If you place a lump of soil in place of water, now take the lump. Lump means what? You can call in Marathi dig. Okay, lump of soil is placed in place of wood. We have placed soil. Now you will find that this crater is whatever I have shown the that black back spot, no, black spot. Okay, so you will find that this crater is bigger than the crater that has been formed on the wood. Okay, whatever the crater from on the soil top surface, it is bigger than the your as compared to wood. Okay, now again the question arises that how your water is able to remove the material from the wood or soil. Okay, we haven't got the answer of that, how that water is cutting the that material, okay, from the wood, or you can consider from the soil also. Okay, now further, okay, keeping all of this structure destructive feature in some sense. Okay, so I just asked a question to all of you. Okay, could you think to make use of this destructive phenomena for some constructive phenomena? Okay, so that because whatever I'm telling, that is a different level, I can call it is a destructive phenomena. Now, if this destructive phenomena, if I will keep for thinking purpose, and if I want to convert into the some constructive phenomena, then in my opinion, okay, then I can say in my opinion, researchers took this destructive phenomena, okay, and they have started thinking on that phenomena, how the water is going to cut, or how this water is going to remove the metal from the wood or or your soil. Okay, so researcher has started thinking, and after thinking, after taking some inspiration from that phenomena, they developed one process, and that is known as water jet machining, WJ. Okay, now how that water is going to remove the metal, that again answer is remaining, and the answer is that water jet machining. Now the principle of the water jet machining is the your answer. Now principle is what? Whatever the kinetic energy, now kinetic energy means the mechanical domain. Okay, mechanical energy domain. So kinetic energy of the water which is flowing through that tap, when it will strike to your workpiece, no, that time the kinetic energy is what? That speed, velocity of the water jet. Okay, when it will strike, that time erosion action will take place on the surface of your wood, or it may be the soil. Then due to that erosion action, the small craters or small that material from your wooden surface, it will remove. So that action I can call material removal action. But to remove the material from the your wood piece or that soil, it takes time. Huh? Okay, so kinetic energy of the water that makes to remove the material from the your material. Okay. Now, in case of water jet, the question are just what will be the velocity of your water jet? So generally the velocity of water jet is as high as up to 900 meter per second, up to 900 meter per second. Okay, so here kinetic energy of your water jet, that makes it happen, that removal of the material. Now same way, okay, same way in a rainy season, if you check the water coming out of the tap, okay, water is coming out of the tap. In some houses, you may find that some sand particles are mixed in the water stream. Okay, now you can see the second, sorry, second figure. So here, whatever the water in the rainy season, whatever the water is coming in our house, okay, that is mixed with the some sand particles. Okay, in that water stream item. When these sand particles, whatever I have shown, is there no in this. So these sand particles, along with the water jet, comes, and when it was hit or when it is strike to that stone block. Now if you have considered here, if you take the example of stone block, when if you see that continuous striking of the water plus the sand particle, when it happens on the your stone, you will find after a few months, you can take example a few months or few days, there are so small craters will be formed on the stone. Okay, here again question arises, how this jet of water mixed with the few sand particles is able to remove the material from that workpiece, which is as hard, that stone is hard than the water. Okay, because it is not possible to remove the material using the water from the stone, because stone is hard than the water. But this phenomena also destructive. Okay, but it is possible using the some solution, and that solution means the our advanced machine process. Okay, if you combine the sand particles with the water stream, and if you strike that water stream along with the sand particle on the your workpiece, which is harder than the your that water, then also it is possible to remove the material, or to remove the craters from the your hard material. Okay, maybe the your stone, or another situation is that if you take or if you replace your stone using aluminum, then you will find that bigger craters has been formed on the your aluminum block also. Okay, so again question is that hello, okay, please all of you, please unmute your headphone, that your mic, please go. Let me take. स्वप्निल स्वप्निल okay, so I was talking about when if you replace that stone by the aluminum block or aluminum piece. Again, the question is that how you can make use of this destructive phenomena for some constructive purposes. So again, the answer is yes. You can take help of this destructive phenomena for the constructive purpose, and like that, some researchers has taken inspiration from that phenomena, and they have developed again another process, and that process is called abrasive water jet machining. Now abrasive water jet machining is what you have seen that here. What we have done, we have taken the water, and in that water stream we have added the sand particles. Now that sand particles you can consider the abrasives. Okay, so abrasive plus your water jet machining process, so it is called abrasive water jet machining. Okay, simply. Okay, here also whatever the kinetic energy of your water okay, along with the abrasive particle. When it will strike on the your workpiece, then that workpiece may be harder than the your that water stream. Okay, then the kinetic energy makes it happen to remove the material from that your workpiece. Okay, so this is called the abrasive water jet machine. Okay, very simple funda. Okay, kinetic energy of water that makes it happen to remove the material. Okay, so material removal, how it is going to remove? Using the average that erosion action. Okay, if you strike that continuous water stream, then from the your workpiece, after some the period of time, the material will be removed, and that material will be removed in the form of craters. Okay, so this is a principle behind the our abrasive water jet musting and water jet musting. Okay, now like that, like this, there is a third process in this slide also. You can see third diagram. Okay, so this is third process. Here a jet of air and your abrasive particles is coming out of the nozzle. You can see here at the top I have shown that nozzle is there, and out of that nozzle you will get the air plus abrasive particles. Okay, here I have shown the direction also. So that is a nozzle. Okay, and that jet of air and abrasive particles are coming out of that nozzle. When this jet comes out and when it will hits, or I can say strike this stone, no, okay, stone block, then we find that crater has been formed over here also. Okay, crater has been formed over here. Over here means what? On the surface of your stone. Okay, now you can take another situation. In place of this stone, if you place the aluminum block, then a bigger craters has been formed as compared to what was formed on the stone. Okay, here second you can see aluminum block is there, and from the top surface of that aluminum block, bigger craters has been formed. Okay, now again you can consider if you view in the conventional way, then whatever our stone is there or the aluminum metal, it is harder than the your that jet of air plus abrasive. But as per this phenomena, it is possible to remove the material from the your stone as well as the aluminum using the air plus abrasive jet. Okay, now again this is called the destructive phenomena. Okay, again this is called destructive phenomena. Again, some researchers from the manufacturing sector, they have started thinking, and they have gone for constructive phenomena, and that constructive phenomenon means what? The development of new advanced machining process, and that new advanced machining process, it is called abrasive jet machining. Abrasive jet machining. Why it is called abrasive jet machining? Because whatever our air is coming from that nozzle, that air will act as just the carrier gas, and in that air we are mixing the abrasive particles, and that abrasive particles, it is called air abrasive jet. And when that jet is going to strike, or when it impinge, or when it is hit that stone or your workpiece, which is maybe made up of the aluminum or other, then the kinetic energy of that air plus abrasive jet, that makes it happen, that removal of the material. Okay, again here the erosion action makes happen to remove the material from the your workpiece. Okay, so this is the basic principle behind the our water jet machining or abrasive jet machining or abrasive water jet machining. Okay, understood? Why it is called mechanical energy based process? Because kinetic energy use. Now kinetic energy of your water, or kinetic energy of your air, that is carrier gas. Okay, so we are getting from now what is the system, or what is the whole setup of this all process, that we are going to learn in the chapter number 2nd. Here we are taking just the overview. Okay, so I think you got the principle behind these three processes. Okay, have you got understood or not? Say yes or no so that I can proceed further. In chat box say yes or no. If yes, I can proceed further. If no, I can repeat once again.
Sir, can you repeat?
Okay. For which process or all process?
Water jet machining.
Okay. Sure. Now, in water jet machining, now I will not take the example of that tab and all this. Huh? Suppose we have the jet of water. Okay, jet of water means what? Having the surrounding like pipe or some nozzle. And if that water is coming with the high speed, okay, near about 900 meter per second, then I can call that water jet. Okay, having the velocity 900 meter per second. Okay, now jet means what? Having some speed or that velocity. That means it contains or it carries some kinetic energy. Okay, now that kinetic energy comes from the mechanical energy. Okay, because we are taking that water from the one of the reservoir. Okay, using the pump, we are taking the water from the reservoir. Then that water, by pumping that using the pump, it is going to your that wall and other things. Okay, so that you will get the high velocity. Okay, so now I can call high velocity water jet coming, okay, along with its kinetic energy. And when that high velocity water jet, when it will strike, when it will impede, when it will hit the any material, okay, and in that any material, here I have considered your wooden block, okay, or wood piece or soil. Now, when it would strike, no, if it will striking continuously, then after some period of time, what you will observe, you will you will get that from the top surface of your that wooden block, some material is removed in the form of craters. Now, question arises how the metal is removed. Now, how? The answer is that the impact of the water jet, now impact, how you are going to impact due to the kinetic energy, and due to that kinetic energy, when it would strike continuously on your workpiece, then erosion action will take place, and due to that erosion action, matter will be removed from the your workpiece in the form of small craters, okay, or small that particles of your, and like that if continuously striking will happen, no? The whatever you want that shape on your workpiece, that shape you can form on your or in your workpiece. Okay, for example, if you want to form a shape like drill, okay, five you can take a 50 drill, okay, having the diameter 20, then that is also possible using the water jet. Okay, continuously that striking of water should be there on your workpiece, and then due to that kinetic energy of water jet, the erosion action will take place, and due to that erosion, material will be removed. Okay, now understood. Like that water, if you add some sand particle, okay, now that sand means the it is a abrasive. Now there we have the different types of abrasive, okay, that we are going to see in the chapter number 2 in detail. So in water, if you add some sand particle and if you strike that water abrasive jet on your stone or other material like aluminum, then also due to the erosion, material will be removed. So that time the process is called abrasive water jet machining. Now, third way or third situation, if in place of water, if you are taking the air having the high speed, okay, high pressure also, okay, now here we are going to take from the one reservoir, then we are going to use intensifier or the compressor to compress that air, and to increase its pressure we need intensifier. Okay, now that high velocity high pressure air is going to come up to the nozzle, and in that nozzle, if you mix some abrasive particles in that air, then air plus abrasive jet is going to form, and that air abrasive jet having the high velocity, if it will strike on the workpiece, okay, like stone or the aluminum, then due to that kinetic energy, the impact will be there on your workpiece top surface, and due to that kinetic energy, erosion action will be starting, or that erosion action, due to that erosion action, material will be removed from the workpiece in the form of small craters. Okay, that time that process is called abrasive jet machining. Got it?
Sir, can you give me an example of water jet machining? Which type of material we are cut?
Now, here first is the wood. Okay, wood. Then whatever the our big fish are there, no, or meat. Okay, for that purpose, water jet machining is used. Now, in some cases, I'm going to say, give the some examples. Okay, like cutting of the our material like stone also. Okay, we can use the water. Okay, but if you use this water jet machining for cutting the stone, it will take very high time to cut that, because it is not easy to cut that stone using water. It is possible, but it is time consuming process. Okay, because every process has a limitation. Okay, now if you take these three process, okay, using these three process you can cut the wood. Okay, but out of these three, you need to choose the one best optimal solution. Now how best you are going to select? Okay, using the time consumption. Okay, within less time we need to cut, and also shape whatever you want to shape on your workpiece, that should be the accurate. Okay, so that water jet machining you can use for that wood, or the that fish cutting purpose, or that your meat cutting purpose. Okay, like that we
Sir,
have the
can we
application.
use to cut the material of fiber from water jet machining?
Now, fiber, it is not possible using the water jet machining. Okay, for fiber we have the another process. Okay, because for that purpose I have mentioned that for some processes we have the limitations. Okay, for fiber we can go using the another process. In the second chapter we are going to see the application of each and every, because here we are using, if you take the consider, or if you take the example of the our first, that water jet machine, there we are using only water. Okay, now for example, using water, if you are cutting the for example mild steel workpiece, okay, then craters will form. That crater will mix with the water on the top surface of your workpiece, correct? Then if the craters will be the on your workpiece, then whatever the impact of the your water jet, okay, you are getting when the clean surface is there, no, that impact you will not get when the craters will be there on your that workpiece. Okay, so normally whatever the water jet machining process is there, you know, that is used for the normally that to remove the unwanted coating, okay, or for surface preparation is there, no, okay, to remove the unwanted I'm telling coating. Okay, again for the cutting or cleaning of the rust or residue particles, no? Rust particles. Okay, or we can call for the polishing also, that time we can use. Okay, again if you take the that metal and non-metal example, then also we can use the water jet machining, but for some just a surface structure. Here we are not will not get the some accuracy, good accuracy. Okay, but here this process will consume more time. Okay, for cutting the that hard metal. Okay, hard metal means you can for example, if you want to cut the that carbide, okay, using water jet, then it is very difficult. Okay, next,
Yes, sir.
again, any question, please ask. So like this discussion should be there. Otherwise, one-way communication will be there.
Sir,
Just I am
fiber
telling
is
that.
softer than wood, so why we not cut by water jet machining?
Now, when that cutting will start, no, that fiber particles will be there. Okay, and that fiber particles will not go anywhere. Okay, that will stick to the your surface. Okay, then layer will form. Now, in between your surface, okay, clean surface, and your jet, water jet, there will be the that some small layer of your crater. Okay, now that crater of your, you can take fiber. Then whatever the kinetic energy you will get from the water jet, when it will strike to the your surface, no, in between that some kinetic energy is going to loss due to the that small layer of your fiber. Okay, I am telling the small layer, correct? For example, when your clean surface will there, that time if you are getting the 19 meter, sorry, 900 meter per second velocity, and in between that, okay, your that jet and your that surface, in between that if you have some another small layer of the fiber or for other, then definitely there will be the loss of energy. If energy is less, then whatever the impact or the whatever erosion action is going to place, no, that is not faster than your clean surface. Okay, it will take some more time, okay, to remove the material. I'm not saying that material is going material will not remove from that surface. That material will be removed, but it will take more time. Okay, so normally, again, okay, to remove the material we have the one system. Okay, in our system part, in the second chapter we are going to see the which are the component or which are elements we are using for the water jet machine or for other also. Okay, but for every material every process we have some limitation. Okay, we can cut wood, soil, okay, or some other that coating removal or dusting purpose, rust particle or some surface preparation purpose. Okay, we can use. Okay, but if you want to remove that material, okay, having the hardness more that lower less or high. Okay, because now the fiber having we know that thickness is very low for fiber. Okay, so that time we can go for using another material, no? Okay, next.
Yes, sir. Yes, sir.
Over.
Yes, sir.
Okay, we'll go further. Okay, when we are going to study now each and every from start chapter number 2, that time I am going to explain that application and other things. Okay.
Yes, sir.
Okay, here I have not added one figure because okay, but just theoretically I can say. Now there is called another process. Okay, 1 minute. We were discussing about the mechanical. Now ultrasonic machining. Now this is a fourth one, mechanical energy based process. Okay. Now here we are going to use the transducer to get the that vibrations. Okay. From the that whatever the electric energy is going to there, no, that we are going to convert into vibration. Okay, now to convert, now vibration will act as a mechanical domain. Okay, now that mechanical energy in the form of vibration, when it will give the air it's a vibration to the some that medium, and that some medium is what average slurry will be we are going to use in between your workpiece and your that that vibration element. It is called the normally tool holder or the transducer. You can call transducer is used to convert the that electrical energy to your vibration. Okay, now in this slide you can see in this process normally tool. Okay, now what are the tool we are using conventional? Don't consider like that. Okay, tool will be the like one holder tab will be there. Okay, so tool that whatever we are going to use a tool in case of the ultrasonic machining, that tool is going to vibrate at a ultrasonic frequency. Okay, now ultrasonic frequency means that how much? Okay, more than 20,000 hertz. Okay, that means 20,000 times per second that tool is going to vibrate, okay, with certain amplitude of that vibration, because we know that vibration having its amplitude and frequency. So it will have some amplitude and it will have the high frequency near up to or more than the 20,000 hertz. Okay, and between your that tool and your workpiece there is a one medium, that medium. Okay, and that medium is the slurry, abrasive slurry is we are going to use. Okay, which is consist of the liquid. That slurry means the liquid plus some abrasive particles will be there. In this figure I have shown. Okay, now when it will that tool is going to when it will vibrate, no, then that vibration is going to is going to transfer to your abrasive slurry, and then that whatever the abrasive slurry in that vibration will be there, no, that due to that vibration again mechanical impact will be there on your top surface of the workpiece, and due to that impact material will be removed, okay, in the form of small craters. Okay, now how we are going to get the vibration, okay, which device or which elements is going to use, that in detail we are going to see in the chapter number 2. Okay, but here only I will tell, here we are going to use a magnetostrictive transducer. Okay, then we will have the one tool holder, and then in that tool holder our tool will be there, and that when that tool will be vibrate with the high frequency and amplitude, some certain amplitude, then that vibration is going to transfer to your slurry which is in between your tool and your workpiece, and that due to the impact of the vibration or mechanical vibration, due to that impact material is going to remove from the your workpiece. Okay, so this is a basic principle behind the ultrasonic machining. Okay, now ultrasonic means what? Ultrasonic vibrations or that ultrasonic frequency. Okay, because it is more than 20,000 hertz, so that is called ultrasonic frequency. So ultrasonic, using that ultrasonic frequency or vibration we are going to remove the material, so it is called ultrasonic machining. Okay, I repeat, when whatever the tool I have shown, when it will strike that particular abrasive particles, no, then vibration means what? It's a momentum. Okay, that it gets the momentum from your vibration, and that strike with the your workpiece metal. That here I have shown the small particles also, that momentum of your abrasive particle. When it will strike to your workpiece, no, then that time certain kinetic energy will be transported to your top surface of workpiece through that your abrasive particles. Okay, in the form of that vibration. Okay, it means the thousands of whatever the abrasive particles will there, no, it will hit to your workpiece. Okay, because that hitting action will take place due to the your kinetic energy. Okay, which is in the form of vibrations will be there. Okay, that vibration we are going to get from the your tool. Okay, so these particles or other particle when it will strike the workpiece surface, no, that means thousands time, then so every that whatever the hitting will be there, no, in the form of vibration on your that top surface, that time every hit it will create some crater, that means fine crater on your workpiece metal, and like that metal will be removed from your workpiece, and finally the that continuously that hitting will be there, na, then finally you will get the shape of the crater formed on your workpiece surface. Okay, for example, if you want drill or if you want some cavity, then the cavity will be formed after the some time. Okay, for that purpose we have some first we need to go for the some trial and error or some experiments. Okay, how much time is required to get the some cavity or a drill, okay, having the some dimension. Okay, normally now here whatever the cavity we want on your workpiece, no, so same replica of that cavity firstly we have to give to the our tool. Okay, so that some that same replica of the your tool, no, it will create on your workpiece. Now here most important statement is that here no physical contact between your tool and your workpiece. Okay, in between tool and your workpiece there is always small gap, and in between that gap abrasive slurry will be there. Okay, now this ultrasonic machining normally it is used for to cut the hard and brittle material. Okay, because it's having some more capability than the your abrasive jet machining or the water jet machining. Okay, getting out. Because for the application like our drilling or grinding or that other, okay, we can use this ultrasonic machining. Okay, again material maybe like hard material or brittle metallic alloys also, some glass also, or carbides or ceramic. So all materials machining it is possible using the ultrasonic machining. Okay, also you can form a round shape or square shape or irregular shape holes also. Okay, so for that application we can use this. I repeat once again, using magnetostrictive transducer we will get the vibrations, and that vibrations we can take from the transducer to tool, and then tool will vibrate. Okay, and in between tool and your workpiece there is always small gap, and in between that gap abrasive slurry will be there. The abrasive slurry means what? Your liquid plus the abrasive particles. Okay, so a slurry will be formed, and what are the magnet that vibrations will be there at the tip of your tool, no, that vibrations is going to transfer to your abrasive particles, and due to that impact that hitting of the your abrasive particles on your workpiece top surface, the material removal will be happen. Okay, any doubt? Understood or not? Say yes or no so that I can proceed further, or you can ask me additional information. Okay, once again I am repeating, here we are taking only overview. In detail we have the syllabus of next 5 chapters, next 4 chapters. Okay, because same processes whatever I have explained today, no, that ultrasonic machining, that water jet machining, then that abrasive jet machining, all these 4 processes in detail again we are going to learn in chapter number 2. Okay, chapter number 2 is related only these 4 processes. Okay, because of that the name of this topic I have given the overview. As per syllabus also it is called overview. That time also we are going to see the working principle, then the different elements or the setup we can call, okay, in detail. Then its advantages, applications, how the metal removal rate is going to change with respect to some different process parameters. Okay, all these things. Understood or not? Here for these 4 processes only mechanical energy is used, and that mechanical energy is in the form of kinetic energy. In case of ultrasonic machining, we require high frequency, and that high frequency is the ultrasonic frequency more than 20,000 hertz. Okay, with certain amplitude of that vibration. And using ultrasonic machining, we can cut or we can go for the machining of ceramic material or your alloys or your carbide also, hard and brittle materials. Okay, because due to this only, in the last lecture I will explain that classification. Okay, with respect to or based on the properties of workpiece. Okay, which is to be machined. In that I have explained some processes is applicable for only electrical conductive materials. Okay, or some processes are there which is used for electrical as well as non electrical conductive material also. Okay, now uh, whatever I have given explained, no, ultrasonic machining or abrasive machining. Okay, so these processes we can use, or these are processes are applicable for both electrical conductive material as well as electrical non-conductive materials. Okay, please remember this point also. Here there is a no limitation about the properties or the other thing. Okay, but the performance matter or capability matters, huh? Okay, due to that only, the last time also I mentioned that every process having its capability. Okay, four processes will be there to cut same material, but out of four or out of the other also, you need to choose one best. Okay, so that time best means what? You need to check the material removal rate, MRR. You need to check the surface characteristics, that means surface accuracy or surface finish. Okay, here the most important property is that material removal rate. Okay, okay, shall I move for further process, or shall I stop here? What to do? Now we'll stop here. Before that, we'll take attendance. Huh? Please, now all of you, please mention your roll number in chat box.